Hey guys, in this video I will show you how to make this colorful particle animation in Houdini by using flip fluid simulation, so let's dive in. So this animation is inspired by this project. You can find the link in the description, so please check it out. So I have created a new blank scene in Houdini, and the first step is to add a new geometry node. So you can create it and you can dive inside. So the first step is to add a box to create the source for the particles. So let's add a box. And here you can press P to open the parameter. And for the size, I will change it to 6.5, 0.5, and 3.5. So now you can add the match size node. So in that case, you can put the box into the floor. So here you can use the match size, and here for the match size you can put the justify Y to minimum. So in that case you can see the bottom of the box is at 0 on the floor. So now you can create the flip source by using the node called flip DOP source. So for now you can keep everything by default here, and later we can change the size of the particle separation. So now you can add a blast node, and here you can remove the surface, and here you can add a null to specify this is the output of the source. So you can rename it something like out source. So now we need to create a collider for the flip object to get like a container object. So to do that, you can take the output of the match size node here and you can add a blast. And here for the blast, we can specify a group to remove. So here you can visualize the match size node. You can make the primitive number visible by clicking on this. And we have to remove the primitive number 2. So here we can go back into the blast node and you can put 2 here. And you can see that we can remove the top parts of the box. So now you can use a poly extrude node. And here with the poly extrude, we can create some thickness for the container here. And you can put the distance at something like 0.2. So don't forget to click on output box to create the inner faces here. So now you can make the top faces here a bit higher on the y-axis. So to do that, you can select this icon on primitive mode and you can select these faces, this one, and this one. To add selection, you can click on shift on the keyboard, and here with the mouse over the viewport you can add another poly extrude, and here you can just put that a bit up on the y-axis and you can put the value at something like 0.8. So now we can create the collider for the flip simulation. So to do that, you can use a collision source node. So the first input is a collider geometry. So you can add a null to specify this is a col geo. So you can rename it col geo in uppercase. And the second output here is the VDB. So you can add a null. And here you can see it will create a volume based on this geometry. So you can go into the collision source. And here you can go into the volume tab and you can change the voxel size to something like 0.025 to get a bit more resolutions. So you can rename it col vol, and we'll use that later in the DOP network to get the collider for the flip object. So let's create the DOP networks for the flip simulation. So let's add a DOP net, and here you can rename it something like flip sim, and you can dive inside, and here we have to add the flip solver. We have to add the merge node, the gravity node, and you can plug that to the output. So we have to use the flip object and the volume source. So here, let's remove this default cube here. So you can go to the flip object and you can remove that. You can copy the particle separation by right-click copy parameter. And you can go back into the SOP by clicking on Geo1 here, because this is the name of my geometry node. And you can go into the flip source here. You can paste this one here, paste relative reference, and you can multiply that by 2. And here you can paste it here on the particle separation. So paste relative reference. So now you can go back into the DOP networks. And here on the flip object later, we will change the particle separation, but for now, let's keep it at 0.1. So now let's import the source into the DOP network. So to do that, you can select the volume source node and you can import the source into the SOP path. So here you can select it by clicking on this, and the source is this one, out source. You can initialize the flip simulation. So you can click on initialize and you can click on source flip. So now it will create the attribute. So by default, the visualization is with this sphere. So you can go back into the flip object and you can go into guides, into particles, and here you can change this one from sprite to particles. Also on the volume source, we want to emit the fluid only on the frame 1. So you can go into the activation here and you can put $ff is equal to 1. So in that case, the flip will be emitted only on the first frame of the animations. Otherwise, it will emit the fluid over time. So now let's add the static object to get the container that we have created here on the SOP level. So you can import that into the DOP net to create the container. So you can go back here and you can add the static object. You can plug that into the merge and you can press Shift and R to invert these two. So here you can just import the collider geometry into the SOP path here. So you can select the collider geo and here you can go into collisions. You can change this one to volume collisions. You can change this to volume samples. And here you can import the proxy volumes, which is named colvol in my case. So this is this one. So I can click on accept. And now we have the container for the fluid. So now you can set the flip solver. And here you can select it. You can increase the substep to something like 3 and 4 for minimum and maximum. Here into the particle motion, you can add an ID attribute. You can remove the receding. And here you can go into the volume motion, you can keep this one to splashy, but it's up to you, you can change it to swirly if you want. So here we change the volume limit, which is the purple square here. So in my case, I will reduce it to something like 7, 5, and 5, but it depends on the size of your scene. So in my case, I will keep it as it is. And now you can make this one invisible. So now you can go into viscosity, you can enable the viscosity, and you can enable the viscosity by attribute, because later we can control the viscosity by an attribute. As a collider, you can also add a ground plane. So you can add a ground plane here. You can merge these two, which is a container plus the ground plane. So you can select them, plug them into the merge, and here you can put that a bit down here, and you can plug that here. You can remove this one by pressing Y on the keyboard, and you can press Shift R to invert these two. So now we have the two colliders, and now you can go back in SOPs to create the collider to move the particles and get this kind of effect on the particles. So you can go back into the SOP level, and here we can create our moving collider to create the animations. So let's create the moving collider. To do that, you can add a tube. And here for the size of the tube, I will change the radius to 0.15 and 0.15 here. And I will change the column number to 50. So here, don't forget to click on end caps to close the tube object. So now we can create a round shape on the top and of the bottom of the tube here. So to do that, you can select the tube, you can select this icon on edge mode, and you can double click on the top edges. You can double click with Shift on the keyboard to add some selections, and you can double click on the bottom one. So here with the mouse over the viewport, you can press poly bevels, and here you can change the distance to something like 0.17. So now let's add a fuse node, and also on the poly bevel you can change the division to 10. So in that case we have this kind of round shape on the top and of the bottom, and if you want you can add the poly split node to add some edges into the middle part of the tube. So you can change the mode to edge loop, and you can select this one, and you can add some cut here, and you can increase the number of the loop to something like 25. So now you can put this object on the floor. So to do that, like before, you can add the match size node. And here with the match size, you can change the justify Y to minimum. So in that case, the object will be on the floor of the scenes. So now to animate this object over the fluid simulation, we can use a curve. So let's make the box here visible with a pink flag. And here you can select the curve. And you can go into the top view by pressing space 2. And here you can draw a curve into this container. So here you can click on this icon, and you can create a curve to something like this. So of course, the shape of the curve is up to you. You can change it if you want. So let's try to make something like this. So let's add a resample node. And here with the resample, you can change the length to maybe 0.5, and you can put that to subdivision curve. So now we have this kind of shape for the curve. If you want, you can change the shape as you want. And now you can use a path deform node. So you can plug that into the first input, and you can put the curve into the second input of the path deform. And you can go back into the 3D view by pressing space 1. So now let's check the animation of the path deform. So we have our object here, and you can maybe go into the top view by pressing space 2, and you can change the curve position here. So by default, the curve position is at 0. So you can put the collider object into this little square. So you can change the value here to something like this. So in my case, I will put the value at 0.065. So I will add a keyframe at the first frame with Alt and left click on this value. And now I will go into the frame 120, and I will change the value here at the end of the curve to maybe something like this. So now you can add another keyframe by pressing Alt and left click, and here you can select the path deform. You can go into the animation editor. You can press H to make that into the center, and if you want, you can just change the shape of the curve to something like this. So now you can go into the 3D view by pressing space 1, and you can put that into the floor because I think the curve is not perfectly aligned. So you can add another match size node. So here you can change the justify X to none, the justify Z to none, and the justify Y to minimum. So in that case, the collider object will be on the floor of the scenes, and you can see it will move with the path deform node. So now let's create another collider object for the fluid simulation. So let's add a new collision source node. So here we have the collider moving geometry. So you can rename it something like col anim geo. And now we have the collider volume geo on the second output. So you can rename it something like col anim vol. And here you can change the voxel size onto the volume tab. Here you can change it from 0.1 to something like 0.03. Of course, it depends on the scale of your scenes. So now let's import this animated collider into the fluid simulation. So to do that, you can go back into the DOP networks. You can add another static object. So here we have to import the geometry into the subpath here. So in my case, it's called col anim geo. You can go into the collision tab here. You can change that to volume collisions, this one to volume samples. And here you can import the volume into the proxy volume here. And in my case, it's called col anim vol. So here, don't forget to check this this little checkbox to use deforming geometry because we have animated this geometry into the SOPs. So don't forget to check it to get the animation into the DOP. So now you can remove everything here and you can just select these three and plug them into the merge. So now we have our collider. So now let's see the results of the moving collider. So maybe we can increase the particle separation. So for now, let's put the value at 0.05. So now let's see the results of this moving collider. So let's click on play and let's see the result. So you can see that we have the collider moving on the flip simulation and deforming the particles. So now let's create the color into the SOP to transfer the color from the SOPs into the DOP. So to do that, you can go back into the SOPs. So now let's create some colors on this collider geometry, and the colors should be a ramp moving over time. So to do that, let's add a point wrangle. And here with a point wrangle, we can create a first variable, which is the duration of the animation. So let's call it something like float durations. And you can create a channel for this one. So channel float, and you can name it something like animation durations. So now let's create another variable to shift the ramp if needed. So let's create another float shift variables, and you can create another channel float parameter. You can rename it something like shift value. And now let's create the last one, and you can call it something like normalized time. So this one can be equal to clamp, and here we'll use @time variables divide by the durations value we have created into the first line here. So don't forget to put the T on uppercase, and you can use the duration here, and you can add the shift value, and you can put that from 0 to 1. So now let's create a color attribute. So let's type @cd is equal to channel ramp. And here you can give a name to the ramp. So let's call it something like color ramp. And you can use this value. So Control C and paste it here, Control V. So now you can copy this color ramp, and you can create this one by going into this little gear icon, and you can click on Edit Parameter Interface. So now you can select the ramp color, and you can put that into the code. And here you can just paste this one here, and you can rename it something like color ramp. So click on apply and accept. And here you can create the different parameter by clicking on this little icon. So in my case, the animation durations is 5 seconds, 1, 2, 3, 4, and 5, because the keyframe on the pass deform here is from the frame 1 to the frame 120. So the animation is 5 seconds, and you can shift the value if needed. So you can go into the edit parameter interface, and you can select the shift value here, and you can put the range from -1 to 1 instead of 0 to 1. So now you can change the color ramp to maybe something like Inferno, and here you can check the result of the color. So you can see that the color of the geometry is moving over time. So here you can see that the last color is very short, just at the very end of the animation. So if needed, you can tweak the animation duration and the shift value. So in my case, to get a bit more yellow color here at the end, I will change the animation duration from 5 to 4, and I will shift the value here to -0.15. So now let's add another point wrangles. And here with this point wrangles, I will create another attribute called something like f for float at value is equal to 1. In that case, we can put this attribute with the value at 1 for this moving geometry, and later we can use that to control the viscosity of the fluid. So here let's add a null to specify this is the output of the attribute. So you can rename it something like out color, for example. You can name it as you want. So now let's import these two attribute colors and value into the DOP network. So to do that, you can copy the out color node here, Control C. You can go back into the DOP network. And here to import this attribute into the DOP network, you can use SOP solver. So you can plug that into the second input of the flip solver. You can dive inside, and here you can use an object merge to import the object into the DOP. So you can paste the null here, which is out color in my case. So now you can use the attribute transfer node to transfer the attribute from this object to the DOP geometry. So you can plug the DOP geometry into the first input and this object to the second input of the attribute transfer, and plug that into the output. So here for this one, we want to transfer the color attribute and the value attribute. So let's visualize the value attribute. So you can click on that, and you can click on the information node, and you can visualize the value attribute. And here you can see that everything is red. This is because we have to change the value into the condition tab. So you can go into the conditions, and you can decrease the distance threshold to maybe something like 0.15. So now you can visualize the result by going back into the SOP level, and here you can use the DOP import fields. So you can drag and drop the DOP networks into the first things here, and the DOP node is the flip object. So you can go here into the flip simulations, and in my case, it's called flip object 1. So I will click on accept. And here for the preset, I will choose flip fluids. And now you can see the result of the animation. So you can click on play. Maybe you can make that invisible. And you can click on play and see the result. So now I have these two colors because I visualize the value attribute, but of course you can make this one invisible. And in that case, we can visualize the ramp we have created here for the colors. So basically it's from black to yellow. So let's see the result of the simulation here. So you can see that the color is changing based on the ramp we have defined here into the SOP. Of course, you can change different color, but you can also change the color later with the shading with Redshift. So now you can see that the particle is moving based on the collider we have animated with the tube here. But if you want, you can also add one more thing to add some turbulence into the particle here. So to do that, you can add a grid attached to this tube. So maybe you can put that something like here. So let's make these things visible and we can create a grid. So let's add a grid. And here for the size of the grid, by default, the size is quite huge. So you can put that to 1 and you can put that to 0.2. So now you can change the rows to 16 and you can change the column to 65. So now we have the grid like this. And you can start by setting the velocity. So let's add an attribute angle. By default, we can run over points and you can set the velocity up on the y-axis. So to do that, you can set the velocity by creating a new velocity vector. So v at v is equal to set 0, 1, and 0. So now you can visualize the velocity attribute by clicking on these and on the velocity attribute, and you can make this one visible. So now you can see that we have created the velocity vectors up on the y-axis, and now you can just remap the velocity based on the bounding box of the grid. So to do that, let's add another attribute wrangle. And here to remap the value and control it with a ramp, so you can create a new vector variable called something like well pose is equal to rel bounding box, and here we have to type 0 for the first input and add p for the positions. So now let's create a float for the scale, so you can create float scale variables, and here you can use a ramp to remap it and to give a shape to your velocity vectors. And here you can rename it something like velocity ramp, and you can type rel pose.x because we want to target on the x-axis. In my case, the grid is aligned on the x-axis, but maybe in your case, it's aligned on the z-axis, so you have to change this to rel pose.z. So now let's multiply the velocity vector by the scale, so v at v times equal scale. So now let's create the ramp. And now you can see that we can give a shape to your vector here. So we can make it something like this, and like this. So now you can select everything and you can change the interpolation here from linear to B-spline. So in that case, we can create this kind of ramp. In that case, the velocity will be a bit more strong at the beginning of the grid and a bit more weak at the end of the grid here. So now let's create a bit of noise into the velocity because for now everything is perfectly straight. So to do that, you can use an attribute adjust vector, and here by default we can adjust the velocity attribute, and here we can change the direction only, and later we can use another one to change the length of the vector only. So you can keep the operation to add, but you can adjust it with a noise, and here we can change the range here to 0 centered, and here you can change the amplitude vector to 0 on the y-axis. In that case, we can add a noise to x and z vectors, and here you can change the noise type if you want, but in my case I will only change the element size to 0.01. I will also change the offset to 5, and here I will animate the noise by clicking on this, and I will put the pulse duration to 2. In that case, the noise will move over time like this. So now we can add another one to adjust only the length of the vector. So to do that, let's add another attribute adjust vector node. And here we can just change it to length only. And you can keep this one to add, and you can add noise for the length of the vector. So here we can put the minimum to 0, the maximum to maybe 0.3, and you can choose a ramp to get something a bit more clean. So maybe you can put that to something like this. So here you can change the ramp to get more or less vector affected by this noise. So maybe you can put the value at something like between 0.6 and 0.7. I think something like this is quite good. So now let's create a group for this geometry. So you can rename it something like grid vel, for example. And here you can keep that to primitive, and you can put everything into this group. So now you can merge everything together. So you can plug that here and put that here. And you can also change the position of the grid because for now the grid is at 0 on the x-axis. So you can make this one visible, and you can change the position of the grid here to something like minus 0.5. So now you have the grid after the tube here. So now we can plug the merge into the first input of the path deform, and now let's see the result. So you can select the path deform, make it visible, and now you can hide this one, and you can see the results. So you can make the curve visible, and now you can see that it's not correctly aligned into the curve. So you have to go into the path deform, and into the capture and align tab you can change this one to maybe X, so you can see the result. So now let's select the match size node, and here you can add a blast. And here for the blast, you can select the grid, and you can click on delete non-selected. In that case, we can keep only the grid. And now you can add a null to specify this is the output for the velocity. And you can rename it something like outvel. So let's copy this null to import it into the DOP network. So you can select it, Ctrl C, and you can go into the DOP networks. Like before, we will use the SOP solver to transfer the velocity attribute to the DOP geometry. So let's add another object merge. And here you can paste this one here, and you can add another attribute transfer. You can plug this one to the first input and this one to the second input, and plug that one into the output. So for this one, we want to transfer the velocity attribute on the points. And here you can go into conditions, and you can change the distance threshold to something like 0.1. Also, if you want, you can add an attribute wrangle after this to create more or less velocity. So you can just type v at v times equals channel float vel mult. So here you can create this one to create more or less velocity, and you can visualize the velocity by clicking on this, and you can make this one visible, so you can disable the value and keep only the velocity. So here you can change the value as you want, so by default is at 0, so we don't have any velocity, and here you can make it at 1, so this is the default value, but in my case I will increase it to 5. So in that case we have quite strong velocity here. So now you can make this one invisible, and you can go back into the flip. So now let's create the viscosity attribute based on the value attribute we have transferred here with the attribute transfer. So we have transferred the CD and the value attribute, and we can create the viscosity attribute based on the value attribute. So to do that, let's add a pop wrangle. And here with the pop wrangles, we can create two variables. The first one for minimum viscosity. And you can put the value at something like 25. And you can add another variable for the maximum viscosity, and you can put the value at something like 200. So now let's create the viscosity attribute. F at viscosity is equal to lerp. We can use the lerp functions. And here I've made a mistake. This is not the maximum viscosity, but minimum. And here we can lerp between the maximum viscosity for the first value and the minimum viscosity for the second value. And you can use a float at value attribute to make the mix between this one and this one. So F at value. So let's check the results of the animation. So maybe we can decrease it to 0.03, and let's make a preview for the simulations. So now you can see, as we have added the grid for the velocity, the collider here is not at the same position for the path deform. So you can go back into the SOP. And here you can make this one visible in pink. You can go into top view by pressing space 2. And here you can make the path deform visible, and you can change the value here. So in my case, I will decrease it a bit to maybe something like this for the first keyframe. And you can go at the last keyframe, and you can decrease the value to something like this. In that case, we can keep the collider into the flip object. So now let's make a quick preview for the flip simulation. So you can make this one invisible, and you can go back into the DOP networks. So let's click on play, and let's see the result of the animation. So I've simulated few frames to get a preview of the animations, and you can see that we have the collider pushing the particle here, and we have the velocity create this kind of noise after the collider geometry. So you can see, and you can of course adjust the value in the SOP solver if you want to get more or less velocity here. In my case, I put the value at 8, but it's up to you. And you can then go back into the animation. You can put the particle separation a bit lower. So in my case, at the final animation, I use the value at 0.008, and it took around 20 or 25 minutes to simulate everything for 120 frame. So now you can go back into the SOP, and here you can check the DOP import fields, and you can add a file cache node. So here you can name it something like fluid animation. And you can put that to explicit. You can put that into the cache folder and $OS folder. And here you can put that for 120 frame. Delete channel and put 120. So now you can click on save to disk and wait for the cache to finish. So in my case, I won't remake the cache for the tutorial. So I will just open my final scenes to explain how to render the particles. So here to render this particle, you can copy this output node. So you can Ctrl C. And here you can add another geometry node. So let's make this one invisible. And you can rename it something like render particles tutorials. So here you can add an object merge. You can paste it here. And you can add a material SOP node. And you can add a null to specify this is the output of the particles. So you can make out particles. So here you can select the object. You can go to the Redshift object tag. So if you don't have it, you can go to Redshift and add object parameter. And here you can go to particles and you can click on that. And if you want, you can create a p-scale attribute. So here, in my case, I will use the attribute adjust float to create the p-scale attribute. And I have created two values, the minimum value at 0.01 and the maximum value to 0.02. And I have created this ramp. So in that case, I have most of the particles at this value and some of them at the maximum value here at 0.02. In that case, you can create some a bit more natural results. And I think it can be a good idea to do that. So you can plug that into the material here. And if the particles look too big into the render, you can just add another attribute wrangles to create mult for the p-scale. And in my case, I put the mult at 0.35 to get correct size for the final render. So you can plug that here. And in that case, you can use the p-scale here to render the particles with Redshift. So you can click on that. So now you can add areas like DOM if you want. You can add a camera into the top view. So maybe you can go to something like this. Add the frame, maybe let's say 86. You can select the camera number 1. So let me open the render view. So this is the render I have for now. So we don't have any material set into the object. So into the material network here, you can create another one. So you can type RS material builder. And here you can rename it something like particles tutorial. You can dive inside and here you can just create the RS points attribute to get the color data from the SOP into the material here. So let's add the RS point attribute. And you can plug that into a ramp. And here you can plug that to the base color. And here for the ramp, you can choose a preset if you want to. You can select this one, for example. So let's put the yellow value here into the white. And now you can go back into the object. And you can assign this material to the object here into the material node. And you can select the material we have created just before. So in my case, it's called particle tutorials. So now let's see the results of the particles. So now you can see the blending between the color is very sharp. So to avoid this, you can use an attribute blur if you want. And here for the attribute blur, you can just blur the CD attribute. You can put that to proximity and you can put the value at, let's say, 50, for example. And you can see that the blending between the different color is a bit better like this. So now if you want, you can of course change the color. So you can go into the material here and you can choose different presets. So for example, this one or this one. So you can choose the preset you want. You can play with a different color here into the ramp, and that's pretty much it for the tutorials. So if you want to get the project files and many other project files, you can check the link in the descriptions. If you want to get access to premium tutorials, you can also check the link in the description. See you in the next one. Bye bye. That's it for today, guys. Thanks for watching, and don't forget to subscribe to our channel and check artivoxer.com to get premium 3D resources. You can access to this project file with our Artifiles membership. See you in the next one. Bye.